Hello everyone, this is Sanjit sir from Praveen Patil Polytechnic, Bhandar. In this practical, we are doing the practical number 26 of high voltage regulator using IC LM723. This is the practical circuit diagram, and we are mounting on the breadboard these components. Here is a tabular form of the components given required in this practical. So in our practical, this part we are removing. This is to obtain pulsating DC or variable DC that will be applied to the VCC as a VCC supply to the LM723 IC. So this part we are directly feeding from the DC voltage output obtained from a DC regulated power supply. So high voltage regulator IC 723, LM723 is a voltage regulator designed primarily for series regulator applications, and we in the previous lecture, in previous practical also, we have seen its features and all that. So now we'll go to the competency or skill to be developed after completion of this practical is to use discrete electronic devices and voltage regulators. So this is expected after completion of this practical, and relevant course outcome is to maintain IC voltage regulator and SMPS, and practical outcome expected is to build high voltage regulator using IC723 for the given regulated output voltage, that is between 7 volt to 37 volt, and the input that will be applied to LM723 is from 9.7 volt to or nearly 10 volt to 37 volt. Maximum 40 can be applied, but for safety we are limiting it to 30, or from the 32 volt source we can maximum provide 32 volt. Features already we have seen. It can provide a 150 milliampere output current without external pass transistor, and with external pass transistor it can provide up to 10 ampere of current to the external load, and input voltage 9.5 to 40 volt it can be. Output voltage could be from adjusted from 2 volt to 37 volt, and can be either linear or switching regulator. Voltage reference that is internally generated is 6.8 to 7.5 volt. Here we are taking as 7 volt, and short circuit limit is ISC 65 milliampere at RSC 10 ohm, and quiescent current drain is 3.5 milliampere, typically 1.3 milliampere. This is the pin configuration of IC LM723. So unregulated VCC will be applied to pin number 12, and this is the ground, pin number 7, and internally generated reference voltage is near about 7 volt, 6.8 to 7.5 volt, and output voltage is taken from pin number 10, and we are connecting the external series pass transistor, that is so these are the transistors that are connected, BD135, and here we have connected 2N3055 transistor, and this is working as a RSC of 0.15 ohms that can dissipate maximum 5 watt. These two are the potential divider arrangement between pin 5 and 6. So here we can connect a variable load like a potentiometer, and to measure current we can connect a milliampere, and to measure voltage, output voltage, we are connecting a voltmeter across these two terminals. So same circuit is mounted without this portion, that is to produce, this circuit is to produce pulsating DC or a fluctuating DC that we can provide from the supply we have here. Now for the observation table, we are keeping the load at 1 kilo, and by varying the input voltage we are taking the output voltage reading. So for 10 volt we can see here we get for 10 volt input, here 10 volt input applied, we are getting the 7.97 volts. So we are noting it down, we have noted it, and similarly we can increase the voltage, so 12 volt. So now it is 12 volt, and output we are getting is 9.89, here we have noted 9.88. okay, so in this way we are going on increasing the voltage and noting down the current respective output voltage. So in steps of 2 volt, so here it is 14 volt, for 14 12.09, here we got 11.83. so in this way you can note down the readings up to 26 volt. Here we have given and noted the output voltage. So this is the observation table. Now to calculate the output, that is line regulation, we require the change in the output voltage to change in the input voltage. So we have taken the reading corresponding to the input voltage 22 and reading corresponding to voltage 20 volt input. Their respective output is 13.47 and 13.43, so difference is 0.04, and in this way we are getting this line regulation in fraction as 0.02. and in terms of output voltage, here we have converted 0.02 divided by the output voltage. We have taken the mean value 20 and 22 in between 21 and converted into multiplied with 100, so that we convert it into percentage. So we get a 0.09 as the line regulation, that is within the limit given here. So line regulation, here we see 0.5% of the output to 0.001% of output it can range, and we have the 0.09, so that is within the range. Now for the load regulation, we are to kept input voltage constant at 16 volt we have kept, and we are noting down the output voltage and the load current by varying the load. Here we have used a potentiometer as the load here, so this is the load, and by varying it we are increasing or decreasing the load and noting down the load current and noting down the voltage across. So here we have the two digital multimeter. The first one here on the left is showing the current, the load current, and on the right here it shows the voltage, load voltage. So, and this is the input DC voltage that has to be kept constant. We have to vary the potentiometer resistance and note down the readings. So right now it is for 29.3, the voltage we note here is 13.27, and earlier we have noted for 29 milliampere it was 13.30 for 29 milliampere. So we are limiting our maximum current to 29 here for safety. We FL we are taking it as the full load voltage, and no load voltage when the load is not connected. Of course, when the load is removed, the current flowing will be 0 because it is open circuited, but voltage is available. And as we increase the load, the current increases here, and the voltage we see there is a continuous decrease in the output voltage. So this decrease is not desired, but practically it happens due to the losses. So we are calculating for load regulation. We have taken two readings, that is 13.42 volt as the no load voltage and 13.30 as the full load voltage, divided by full load voltage as per the formula, multiplied with 100. Substituting the value, difference we got, and 0.12 divided by 13.30 into 100. So this gives the load regulation as 0.9%. So we have noted down here 0.9% as the load regulation, and line regulation we have got 0.09%. Here we can see the variation in the readings due to the changes in the load. As the load current decreases, we can see there is increase in the voltage, 3.40, now it has 13.40 it has become. Similarly at 4 milliampere, 13.43. So as we decrease the current, the voltage increases. And as the load current increases, voltage decreases. So in this way we can vary and note down the readings and calculate the line and load regulation for the high voltage regulator using LM723. Thank you very much.